Hello everyone. The title of this presentation is Comparison of the Performance of 2016 CMAQ platforms at 12 km and 4 km resolutions. The performance of 2016 CMAQ model run at 12 km resolution was not very good over coastal water cells due to the difficulty in characterizing the land-water interface in the air quality and meteorological models and accurate allocating emission over large emission gradient area. Therefore, we run CMAQ model at 12 and 4 km resolutions and evaluated their performance for 113 monitoring sites over northeastern US. In addition, we did the 2023 model run with the same inputs, except using 2023 emissions and boundary conditions. This presentation will focus on three parts. 1. Comparison of daily maximum 8-hour average ozone. 2. Comparison of diurnal variations of meteorological and emission data. 3. Comparison of 2023 future design values. Our 4 km platform is consistent with the 12 km platform. The WRF data were provided by EPA. The 4 km initial and boundary conditions were based on our 12 km CMAQ run. The emission data are from 2016 V1 FI emission inventory at 12 and at 4 km resolution. This panel shows our modeling domains. The green box is our current 12 km model domain. The smaller light blue box is our 4 km model domain. Results. Part 1. Comparison of daily maximum 8-hour average ozone. This slide shows MDA 8 of ozone mean bias with a threshold of 60 ppb in May and June 2016. 12 km results on left and 4 km results on right. Both platforms underestimated ozone in May and June. For most of those sites, 2 simulations showed similar results. This slide shows the MDA 8 of ozone mean bias in July and August. Again, both simulations showed similar results for most of sites. The very high ozone biases in red and orange color change to gray, light green, or light yellow at 4 km resolution panel, which means that 4 km resolution outperformed 12 km simulation for those 3 sites. This slide shows MDA 8 of ozone root mean square area difference between 4 km and 12 km platform. The cooler colors, such as blue and green, represent ozone simulation improvements. You can see that most improvements are along Connecticut coastal line area. In addition, site Hart Miller Island in Maryland Chesapeake Bay area also show large improvements in July and August. This slide shows MDA 8 ozone time series for sites Greenwich and Groton from May 1st to August 31. Both sites are defined as water cells at 12 km by WRF model. Greenwich is a water cell at 4 km, and Groton is a land cell at 4 km. At 12 km resolution, CMAQ simulated very high ozone in July and August. However, 4 km model run showed much lower ozone values. Those values are pretty close to observations. This slide shows another 2 sites in Connecticut. Stratford and Madison are land cells at 12 km, but water cells at 4 km resolution. Both simulations are similar to observations for most of those days. In July and August, CMAQ at 4 km performed a little bit better than 12 km simulations during the low ozone days. On average, CMAQ simulations at 4 km resolution did not get worse over monitoring sites that were defined as water at 4 km resolution. However, those sites were defined as land at 12 km resolution. Results Part 2 Comparison of diurnal variations of meteorological and emission data. We just demonstrated that 4 km CMAQ did a pretty good job in simulating ozone over coastal monitoring sites. In this part, we'd like to explore the reasons by comparing the meteorological and emission data between 12 km and 4 km platforms over 6 Connecticut monitoring sites. This slide shows the locations of the 6 monitoring sites over a Connecticut coastal line. Sites Greenwich and Groton are defined as water cells at 12 km by Wolf model. The other 4 are land cells. However, at 4 km resolution, sites 1, 2, 3, and 5 are labeled as water cells by Wolf model. Only New Haven and Groton are land cells. Now, let's see how meteorological and emission data impact CMAQ performance at 4 km resolution. This slide shows the diurnal variation of meteorological and emission data during the time period of August 7 to 16 for site Greenwich. The top left 2 panels show simulated ozone and PBL height during the time period of August 7 to 16. The top right panel shows the air temperature profile from surface to 1 km at 1 p.m. on August 13. The bottom 3 panels show total NO2 emissions, total VOC from biogenic emission, and total VOC from anthropogenic emission during the time period. The VOC-NV is the sum of all VOC species from anthropogenic emission before speciation. Here, we converted emission data unit to moles per hour per unit area or gram per hour per unit area so that 12 and 4 km emissions can be compared side by side. Greenwich is a water cell at both 12 and 4 km resolutions. Therefore, the meteorological variables at 4 km are similar to those at 12 km, such as low PBL height and temperature inversion near the surface. However, the total NO2 and VOC emissions at 4 km are much lower than those at 12 km platform. Ozone simulations from 4 km CMAQ are lower than those from 12 km CMAQ and are very similar to observations. Those results indicate that accurate allocating of emissions can improve the performance of CMAQ simulations. Stratford is a land cell at 12 km, but a water cell at 4 km resolution. Because of this land cover change, the PBL height and the surface temperature decrease during daytime at 4 km resolution. A temperature inversion forms at 4 km compared to 12 km Wolf simulation. With temperature inversion and low PBL height, we expected to see higher ozone values from 4 km CMAQ. However, ozone simulations from 4 km CMAQ are very similar to 12 km CMAQ for most of those days. The NO2 and the VOC emissions at 4 km are much lower than those at 12 km platform, which may explain the reason. Westport is similar as Stratford. I'm skipping this slide. New Haven is a land cell at both 12 and 4 km resolutions. The meteorological variables are almost identical between those two simulations. The NO2 and the VOC-INV emissions at 4 km are much higher than those at 12 km platform. However, VOC bias become very low at a 4 km resolution. The increasing of VOC-INV and the decreasing of VOC bias compensate with each other. Therefore, ozone simulations from 4 km CMAQ are still very similar to 12 km CMAQ. Another explanation is that when PBR height is higher than a threshold, the emission value might not impact the ozone simulation too much. Medicine is similar as Stratford as well. I'm skipping this slide too. Groton is a water cell at 12 km, but it is a land cell at 4 km resolution. Due to this land cover change, the PBR height and air temperature at the surface increase during daytime compared to 12 km WRF simulation. The total NO2 and the VOC emissions at 4 km are much higher than those at 12 km platform. Ozone simulations from 4 km CMAQ are much lower than those at 12 km CMAQ, since the PBR height increases dramatically and air temperature inversion near surface disappeared compared to 12 km platform. Results, Part 3, Comparison of 2023 DVFs. We used these 4 different methods to calculate DVFs. Methods 1 and 2 are consistent with EPA guidance. This slide shows the 2023 DVFs by using a traditional 3x3 approach. CMAQ 12 km platform shows that 5 sites will have their DVFs larger than 71 ppb. CMAQ 4 km platform shows 4 sites with DVFs larger than 71 ppb. Susan Wagner is not on the list. This slide shows the 2023 DVFs by using a 3x3 no water method 1 approach. Both platforms demonstrate sites Greenwich, Stratford, and Westport will have a 2023 DVFs larger than 71 ppb. In addition, 12 km CMAQ shows Groton will have 2023 DVF larger than 71 ppb. However, 4 km CMAQ shows Madison will have 2023 DVF larger than 71 ppb. This table shows 2023 DVFs for the 6 monitoring sites over Connecticut coastline by using 4 different methods. For 12 km platform, the 4 different methods giving relatively large different results. The 4 km platform displays consistent results from those 4 calculation methods. For site Madison, the DVFs from 4 km CMAQ are higher than those from 12 km CMAQ. In addition, Westport's 2023 DVFs will be higher than 76 ppb. Conclusions. 1. On average, the performance of CMAQ at 4 km and at 12 km are very similar. 2. In July and August, CMAQ at 4 km resolution significantly improved the ozone simulations over 2 of the Connecticut coastal monitoring sites, 1 of the Maryland Chesapeake Bay area sites, and 1 of Rhode Island sites. Those 4 sites were defined as water at 12 km resolution. 3. For monitoring sites that were defined as land both at 4 km and 12 km resolutions, two platforms have similar performance. 4. CMAQ simulations at a 4 km resolution did not get worse over monitoring sites that were defined as water at 4 km resolution. 5. Our work suggests that for CMAQ, grid resolution plays an important role in modeling ozone along the land-water interface area, where more accurate allocation of emissions at 4 km resolution input the ozone simulations. 6. For most of land monitoring sites, the 2023 DVFs from 4 km platform are very similar to those from 12 km platform. For the 6 monitoring sites along Connecticut coastline, 4 of them have similar 2023 DVFs. For the 2 platforms, monitoring sites, Greenwich and Westport, showed relatively large DVF difference among 4 calculation methods at a 12 km platform, but very consistent DVFs among those methods at a 4 km platform. That's all. Thank you very much.